So the first thing I'm going to do is I'm going to go over each of the different labs that we did in class. So this first one here, you can see is our rate of reaction and the impact that temperature has on the rate of the reaction. And so for this lab, you don't have to have the exact same data, but you should see the same kind of trends. So if you open up your lab and you take a look at this, remember that in order to have a reaction happen, we need to have two things as a part of the collision theory. And so with the collision theory, we need to have the molecules collide in the correct orientation. So we need to have them collide in a particular way. And they also need to collide with the correct amount of energy as well, so that we get that bond to form between them. So if we have a molecule of hydrogen where the two atoms are connected to each other, remember that in a chemical reaction, the bonds are going to break apart, and then that hydrogen needs to hit oxygen in the correct location in order to form a new bond. So the collisions need to happen with a lot of energy, and the collisions need to happen where they're in the right location to make that bond and connect with each other. So when we speed up the temperature, we can think about what happens to the molecules. When we speed up the temperature, the molecules are going to be moving faster. And if those molecules are moving faster, they've got a greater chance of colliding with each other with that correct location, in that correct orientation, and with having enough energy so that way that bond forms. And so if we look at the trend that we see on this data table, when we have the chemical reaction happening at room temperature versus at hotter temperatures, when it's happening at hotter temperatures, the amount of grams per second, the rate of the reaction, is going to happen faster at those hotter temperatures because those molecules are moving faster, so they bang into each other with more energy, and they're going to bang into each other with that correct orientation. If we decrease the temperature, we have to stop and think what's happening to those molecules. Those molecules now are moving around slower, so they're less likely to collide with the right energy, and they're less likely to collide in the correct orientation. So if they don't collide with the right amount of energy and in the correct orientation, that's going to make the rate of the reaction go slower, because now they're not going to chemically react as often because they don't have that energy and they don't have that correct orientation to collide. So we can see in our data table that the rate of the reaction is much slower at colder temperatures than at the warmer temperatures. So again, your data doesn't need to be exactly the same, but your data should be showing the same general trend as mine shows here. So let's answer our conclusion questions. Do the reactions occur faster at higher or lower temperatures? Well, according to our data, the reactions happen faster at higher temperatures. And to explain why, we can use your basic claim, evidence, and reasoning method. Our claim is that the temperature is going to make the chemical reactions happen at a faster rate at hot temperatures and a slower rate at colder temperatures. If we use our data to support that as our evidence, then we can say in our reactions, the rate of reactions was faster at 0.04 grams per second versus when they're warmer versus at only 0.02 grams per second when it was at a colder temperature. So in our evidence, we want to use the data. And then finally, for our reasoning section, we want to explain why it is chemically that happened. So in our reasoning, we want to say that when the temperature is warmer, the molecules are speeding up and moving faster. That faster speed is going to allow them to collide more often because they have more energy moving around, so they're more likely to collide. They also have more energy, so that's going to make it more likely that they will have enough energy to form new bonds. And then also, because they're colliding more often, they are more likely to collide with the correct orientation. So since the molecules are moving faster, because the temperature is warmer, that is going to result in the reaction happening faster because they're more likely to collide with the correct orientation and with the correct amount of energy to make the reaction occur. The next lab I'm going to go over is the effect of concentration on the rate of a reaction. So if you need to, pause the video and open up the concentration lab. The first thing I'm going to do is I'm going to go over the pre-lab questions. So the first thing we need to do is we need to form a hypothesis about how the chemical reaction rate is related to the concentration of the reactant. When we write a hypothesis, we always want to start with the word if. We want to make a statement that if we do something, so that's the first part, we kind of point out what we're going to do in the lab. And then the second part is going to be what is it that is going to happen. So the second part of a hypothesis then continues with the word then. And so your then is then I think that this is going to happen, or then the result is going to be this. And sometimes we even put in the word because, and we give some reasoning for why we think that particular thing is going to happen. So for this particular hypothesis, we would want to say, if we increase the concentration of our reactant, then the reaction is going to happen, and we would fill that in with either faster or slower. And then we would explain why and what the reasoning is. So we might say something like, if the concentration of the reactants is increased, then the reaction is going to happen faster. And our because then would be because the concentration means there's more reactants in the container, more molecules to interact with. And if there's more molecules to interact with, then the reaction is going to happen faster because we're more likely to have more collisions happening so that we can meet the needs of the collision theory, having lots of collisions in the correct orientation and having those collisions happen with the correct speed. So for this particular experiment, our independent variable, remember that an independent variable is the thing that the scientist is changing. So throughout the experiment, you are changing the concentration of the hydrochloric acid. So you used 6 molar hydrochloric acid, 3 molar hydrochloric acid, 1.5 molar hydrochloric acid, and 0.75 molar hydrochloric acid. Each of those different concentrations, the highest one being the strongest and the lowest one being the weakest concentration, that's your independent variable. The dependent variable for number 3, remember the dependent variable is the data that you collect. So with the dependent variable, we want to record what it is that we were recording for each of our labs. So the dependent variable is going to be the amount of time it took for the reaction to happen. And then number 4, why would it be important to clean the magnesium ribbon? Well, it would be important so that we make sure that there's no sort of oxidation, no other chemical on that magnesium ribbon. If we don't clean off that magnesium ribbon, then all of the magnesium is not going to be exposed, and we're not going to have an actually good reaction rate recorded. Just like with our previous lab, you don't have to have the exact same data as mine, but you should see the same general trend. So in terms of our trend that we see, we should be looking at our data and seeing that when we have a higher concentration of hydrochloric acid, the chemical reaction is going to happen faster. And when we have a lower concentration of hydrochloric acid, the chemical reaction is going to happen slower. Again, you don't need the same exact data, but you should see the same general trend. Let's finish this lab up with a claim, evidence, and reasoning conclusion as well. Remember, our claim is the relationship between the concentration of the acid and the rate of the reaction. So our claim can be about a higher concentration or a lower concentration. I'm going to make my claim that the higher the concentration of the hydrochloric acid, and then I'm going to determine if it's going to be faster or slower. So I'm going to say in my claim that the higher the concentration of hydrochloric acid, the faster the chemical reaction is going to occur. You could do the opposite as well if you wanted to. I'm going to make sure that I use evidence. So I'm going to state data from my data table. So I'm going to say how many seconds it took for the high concentration to finish its reaction, and I'm going to say how many seconds it took for the lower concentration, so that way I'm providing evidence to support my claim. And then finally, with my reasoning, I'm going to explain using the collision theory what happens. So I'm going to say that because there is a higher concentration, that is going to mean that there are more reactants. If there are more reactants, they are going to collide more often. And the more collisions that there are between the reactants, the more likely they will meet the needs of the collision theory, which is that they need to collide with the correct orientation and with the correct amount of energy. So if they're colliding more often, because there are more reactants, they're more likely to meet those two pieces that are necessary for the collision theory.